For half a century, a simple guideline shaped our work on the moon. Accurately tracking things from afar was a nighttime job. The sun's glare was just too much. That was the rule. Until now. While the world was looking elsewhere, China ran a quiet experiment that just rewrote the book on space operations. A single laser beam, fired in broad daylight, has huge implications for science, strategy, and the future of who controls the moon. So, let's break down how they did it, and why this is a much bigger deal than you might think. The breakthrough, a shot in the light, alright, so what exactly happened? In a move that quietly redrew the map of space technology, Chinese scientists did something many thought was next to impossible. They fired a laser from a ground station on Earth, hit a small satellite orbiting the moon, and got a clear signal back, all during the blinding light of day. For decades, this type of measurement, called laser ranging, was a lot easier at night. While daytime laser tracking of satellites orbiting Earth has become common, extending that to the vast Earth-Moon distance was a completely different beast. The sun's overwhelming glare was considered a deal-breaker, washing out any faint, returning signal. It's like trying to spot a candle flame from miles away while a stadium spotlight is pointed right in your eyes. The series of experiments, which took place around April 2024, involved the Tianzhu-1 satellite, a small test craft orbiting the moon since March of that year. From the Yunnan Observatories in southern China, a team aimed a newly upgraded 1.2-meter telescope and fired laser pulses into the sky. Those pulses traveled roughly 384,000 kilometers, about 238,000 miles, struck a tiny reflector on Tianzhu-1, and bounced all the way back to Earth. This wasn't a lucky shot. It was a repeatable demonstration of a capability that's a world first, successful daytime satellite laser ranging in Earth-Moon space. On paper, it's a tech breakthrough for measuring deep space orbits with incredible precision. But in reality, it's so much more. This achievement isn't just about measuring distances, it's about changing our access to the lunar environment. And to get why, you first have to understand just how difficult this was. How they did it, conquering the sun. So, what was the secret? How did Chinese scientists succeed where others were stuck waiting for sunset? The whole game comes down to signal-to-noise ratio. The light from our sun creates an insane amount of background noise. The returning laser pulse, after traveling hundreds of thousands of kilometers and back, is unbelievably faint. Picking that tiny signal out of the sun's glare is a monumental task. The team at the Yunnan Observatories couldn't just build a more powerful laser, they had to build a smarter one. Their solution was a sophisticated near-infrared laser ranging system, designed with one goal: crush the noise from the sun. They combined this with high-speed, automated tracking that could make real-time corrections, filtering out the sun's blinding light with such precision that the faint returning laser pulse stood out. Let's be clear, the engineering here is impressive. Hitting a fast-moving satellite at that distance requires incredible pointing accuracy. Now imagine doing that while a hurricane of light is trying to blind your sensors. It's a feat that shows a level of technological maturity that has caught many by surprise. By solving the daylight problem, China hasn't just made a small improvement. They've potentially unlocked the other 12 hours of the day for high-precision tracking. Why it matters, the scientific revolution. So what does this actually mean for exploring space? The implications are huge, and they start with the science. For a long time, highly precise laser measurements in lunar space were largely a nighttime affair, creating a massive bottleneck. But it's important to remember that missions have always been navigated 24/7 using reliable radio-based techniques. Think of this new laser capability as adding a powerful, ultra-precise tool to the toolbox. By cracking daytime ranging, China has opened the door to more persistent, high-precision tracking around the moon. This is a key enabling technology for their planned International Lunar Research Station. When you're building a base on the moon, you need to know exactly where every person and piece of equipment is, all the time. You can't afford to wait for nightfall to get your most accurate location data. This breakthrough provides a continuous, high-precision data stream that's essential for complex, long-term operations on another world. More broadly, this is a critical step toward creating a robust navigation system for all of Cislunar space, the vast region between Earth and the Moon. Right now, we don't have a dedicated GPS for the Moon. This technology is one of the building blocks for that kind of system. It enables safer landings and better coordination of missions, a key move towards constant awareness and control. The strategic implications, a new arena, and this is where the story pivots from pure science to global strategy. As with any powerful new technology, you have to look at its dual-use potential. A laser that can track a satellite for navigation can also be used for surveillance. The ability to precisely target and track a satellite in lunar space during the day shows a level of targeting skill that can't be ignored. While tracking an uncooperative spy satellite in low Earth orbit is a different challenge, the underlying technologies are related. This new, proven capability in deep space raises the stakes. The U.S. Space Force has openly stated that China is developing capabilities that could threaten American assets in space. This daytime laser experiment, while presented as a scientific achievement, serves as a powerful demonstration of targeting and energy projection technologies. It's a reminder that space has been an arena for strategic competition since the Cold War, and this development marks a new phase in that contest. A choice for humanity. So, what's the bottom line? This single experiment has pushed the boundaries of what's possible, accelerating the new space race in a big way. It gives China a distinct advantage in its quest to build a permanent presence on the moon, allowing for operations with a level of precision that was previously out of reach. In response, the United States and other spacefaring nations will likely speed up their own investments in similar technologies, not just for exploration, but for defense. Yet, we should also take a moment to appreciate the human achievement here. This breakthrough is a testament to ingenuity, a story of overcoming a challenge that had stumped scientists for half a century. It's a powerful reminder that we are still a species that explores, pushes boundaries, and solves problems once thought impossible. This technology is a tool. It can be used to build a peaceful, permanent human presence on the moon, unlocking new scientific discoveries and expanding our civilization into the cosmos. Or, it could be used to extend earthly conflicts into a new domain. The choice, ultimately, will be ours. And that brings me to a question for you. Do you see this as a monumental step forward for peaceful exploration, or do you see it as a warning shot in a new era of space competition? Let me know your thoughts in the comments below. If you enjoy breaking down the tech and geopolitics that are shaping our future, make sure you hit that subscribe button and turn on notifications. We explore these complex topics every week, and you won't want to miss what's coming next. Thank you for watching. Keep looking up, keep asking questions, and never lose your sense of wonder. The future is out there, and it's arriving faster than ever.